Hello, hello, good morning, children. Our lesson for today is about greatest common factors and its method. Of course, with me, Mamaritan. Let us start our day with a prayer. We thank you this day as we begin the class, praising you and always be reminded that all these are in your name. Guide us in our lesson, and open our hearts to enable us to follow your will. Amen. Okay, good morning again, children. So, before we start our topic about greatest common factor, let us recall and complete the factor tree and write each number as the product of its prime factors. So, are you ready? So for number 1, we have 24. So what do you think is the number missing? Being multiplied by 4, the answer is 24. Okay, amazing. It's 6 because 2 times 3 below here is equal to 6. And 6 times 4 is equal to 24. What about 4? What are the two numbers being multiplied? The answer is 4. Very good. So 2 times 2. So now the prime factorization of 24 is equal to 2 times 2 times 2 times 3. So that's it. Let's go for another number. Let's have 54. So this time, what is the other number being multiplied by 9? The answer is 54. Correct. It's 6 because we have here below 2 times 3 is equal now to 6. And 6 times 9 is equal to 54. What about 9? What are the two numbers? What are the two numbers being multiplied? The answer is 9. Amazing! So it's 3 times 3. So now our prime factorization for 54 is equal to 2 times 3 times 3 times 3. Another number, 63. So this time, class, we have another number missing being multiplied by 9. The answer is 63. What do you think is it? Correct. It's 7. So this time, class, we will bring down 7 because it's already a prime number. What about 9? Let us factor it out. What are the two numbers being multiplied? The answer is 9. Correct. It's 3 times 3. So now the prime factorization of 63 is equal now to 7 times 3 times 3 or 3 times 3 times 7. Okay, so let us try the missing number here using continuous division. So at my right side is uh, the smallest, the 5 consecutive smallest prime numbers. This will be your guide in dividing this number. Okay, so how we have 66. We divide 66 by 2. How many is the missing? Okay, correct. It's 33. So now, we will divide 33 by 3. What is the answer? Good job. It's 11. So now, there is no more prime factor aside from 11. We cannot divide it 1, okay, by itself na lang. Okay, so now, the prime factorization of 66 is equal to 2 times 3 times 11. Let's have another number, 48. Let's do again the continuous division. So 48 divided by 2 is 24. What do you think is the number being divided by? The answer is 12. Correct, it's 2. So now 12 divided by 2 is, good job, 6. And 6 divided by 2 is 3. So that's it. Now, the prime factorization of 48 is equal to 2 times 2 times 2 times 2 times 3 is equal now to 48. So, let us have our story problem. So, Mitch and Mickey are twins. Today is their birthday. So, happy birthday, Mitch and Mickey. Now, Mitch has brought 24 pieces of banana to share in class. And Mickey has brought 18 apples. So we have 24 pieces of banana and 18 apples. If they want to share their fruits with their friends in such a way that all their friends have the same amount of each type of fruits, and they give out as much fruit as possible. So the question is, what is the greatest group of fruits can they make? Okay, so in analyzing the problem, class, we have 24 pieces of banana and 18 pieces of apple. In listing factors, we can write the factors of 24 first. So we can multiply 24 by 1 times 24. The answer is 24. And we can also multiply 2 times 12. The answer is 24. And 3 times 8, the answer is 24. And 4 times 6 is the answer is 24. By listing all the factors of 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. While in 18 apples, we have 1 times 18, 2 times 9, and then 3 times 6. By listing all the factors of 18, we have 1, 2, 3, 6, 9, and 18. By getting the common factors, we have first 1, another number is 2, and another number is 3. And the biggest number is 6. So in finding the most or the greatest number from all the factors that we have in 24 and 18, the greatest among them is 6. Now class, this is one way in finding the greatest common factor by listing all the factors that we have. Okay? So let's try another method. Another method is what we call the prime factorization or the factor tree. Okay, we have 24. By factoring out, I choose 4 times 6. And then by factoring out 4, we have 2 times 2. And then factoring out 6, we have 2 times 3. How about 18? So by factoring out 18, we have 2 times 9. And then bring down 2 because it's already prime. By factoring out 9, we have 3 times 3. Okay, so let us list down all the prime factorization of 24, which is 24 equal to times 2 times 2 times 3. While in 18, we have 18 is equal to times 3 times 3. So we have the common factors. The 2, bring down 2, and the 3, bring down 3. By multiplying the numbers, we will get the greatest common factors. So by 2 times 3 equals 6. Another way is the continuous division. Okay, so we have two numbers here. So we will consider the two numbers which is divisible by the common factors. So I'm assuming that the common factors are listed on my right side, 2, 3, 5, 7, 11, or 13. So as as I look, 24 can be divided by 2 and 18 can be divided by 2. So let's start with 2. Okay, so 24 divided by 2 is 12. 18 divided by 2 is 9. So now, 12 can be divided by 2, but 9 cannot be divided by 2. So let's proceed another divisible. So 12 can be divided by 3, and 9 can be divided by 3. So we choose now divisible by 3. So 12 divided by 3 is 4. And 9 divided by 3 is 3. So this time, class, 4 can be divided by 2, but 3 cannot be divided by 2 because it's already a prime number. So there is no more common prime factors. Now, by choosing the common factors, we only have 2 times 3. Okay? By getting the greatest common factor, we will multiply 2 times 3 equals to 6. So remember, class, in continuous division, the GCF is in your left side. Okay? So that's it. So let us go back to our problem. What is the greatest group of fruits can they make? So from 24 bananas and 18 apples, the greatest group of fruits can make is 6. So we have 6 pieces of banana and 6 pieces of apple. Now, class, the greatest common factor, or the GCF, is the biggest or the largest factor of two or more numbers. When we find all the factors of two or more numbers, and some factors are the same, the largest of those common factors is the biggest or the greatest common factors. Okay, let us try this example. List the five several factors of each number. Look for the common factors and find the GCF. For number 1, we have 12 and 16. So by getting the listing factors, we have 1 times 12, 2 times 6, and 3 times 4 for number 12. For number 16, we have 1 times 16, 2 times 8, and 4 times 4. Listing the factors of 12, 1, 2, 3, 4, 6, and 12. Listing all the factors of 16, 1, 2, 4, 8, and 16. By getting the common factors, we have 1, 2, and 4. Now, the GCF here is 4 because the biggest factors is 4. Did you get it? Another method. Let's let us try continuous division. So again, we will consider the two numbers if they are divisible to each other. Okay, so since 12 and 16 can be divided by 2, let's start by 2. 12 divided by 2 is equal to 6. 16 divided by 2 is 8. So now this time 6 and 8 is also divisible by 2. So let us divide. 6 divided by 2 is 3. 4, 8 divided by 2 is 4. So this time, there's no more common prime factors because 3 cannot be divided by 2. Now, the greatest common factor here is 2 times 2 is 4. Next number, number 2, 10 and 15. By listing factor, we have 1 times 10, 2 times 5. By 15, 1 times 15, 3 times 5. By listing the factors of 10, 1, 2, 5, and 10. By listing factors of 15, 1, 3, 5, and 15. By getting the common factors, we have 1 and 5. So the biggest or the greatest common factor here is 5. Another method is what we call the continuous division. So again, we will consider the two numbers, okay? 10 can be divided by 2 but cannot be divided by 15. Okay, so let's proceed for number 5 because it's both divisible by 5. So 5. So 10 divided by 5 is 2 and 15 divided by 5 is 3. Now, there is no more common prime factors, okay? So the greatest common factor here is only 5. Another number, number 3, 15 and 21. For number 15, listing the factors, we have 1 times 15, 3 times 5. For 21, 1 times 21, 3 times 7. So 1, 3, 5, 7 is the listing factors of 15, while in 21 is 1, 3, 7, and 21. Now, the common factors here is 1 and 3. The greatest common factor is equal now to 3. Another method is continuous division. So now, 15 and 21 can be divided by 3. So let us divide. 15 divided by 3 is 5. 21 divided by 3 is 7. So there is no more common prime factors aside from number 3. So the greatest common factor here is equal to 3. Okay, in addition class, if we have 15 and 32, let us find the common factors and getting the GCF. Okay, by listing all the factors, 15, 1 times 15, 3 times 5. 32. 1 times 32, 2 times 16, 4 times 8. Now, listing all the factors. 15 is equal to 1, 3, 5, 15. 32 is equal to 1, 2, 4, 8, 16, and 32. By getting the common factors, we only have 1. So, the greatest common factor is 1. So remember class, there is no zero common factor aside from 1. Okay? And again, by continuous division, we have 15 and 32. Since, again, we will consider the two numbers that is being multiplied by the prime numbers at your side. So, there's no more common factor aside from 1. So, 15 and 32, the common factor here is 1. Okay. So now class, for your assignment, find the GCF using the continuous division. So remember class that you need to consider the two numbers that is being multiplied. Okay, so I'm expecting you to turn in your work in our Google Classroom. And for that, thank you very much for listening and have a nice day, class. Goodbye.